Say that we have two sets, set A and set B, and let me define A to be the real set of all real numbers. I'll denote it with R symbol, and set B is the same. Set B is also the set of all real numbers. So both of the sets are non-empty, so you can define a relation from A to B. So let me define a relation K from A to B. And if I write it in a better way, well, this is actually a relation from R to R because we know what the sets are. This will be a relation from R to R. So instead of saying K is a relation from R to R, people often call this K is a relation from, instead of saying from R to R, people call this K is a relation on R. So there is just a shorthand kind of language for calling something being a relation from something to something. You call it a relation on that something. Well, I'll define the relation in a very specific way. So K is a relation on R such that it will be all the ordered pairs x comma y, where x and y are again taken from your domain and codomain. This is called the domain, this is called the codomain. The place where first entry comes from is the domain, and the place where second entry comes from is the codomain. And I am defining it as the set of all x comma y's such that x squared is equal to y. So this is defined in a very specific manner, right? This is just a subset of R cross R, and it is just that subset where the first entry is actually the square of the second. So no, that will be just the opposite. The second entry will be the square of the first entry. This would happen for all x belongs to R. That is understood, but let me also write x comma y belongs to R. That's why we are taking x's and y's. So now if we write down the relation in the roster form, if we just try to get a hang of it, what can the relation be? So the set K, I wouldn't be able to write the whole relation because the both are infinite sets. There will be infinite number of elements, but let me just write a few elements. So what are the elements where if you square them you will be getting the second entry? Well, if I write down 2 here, then 2 squared has to be 4, so that would form my second entry. So 2 comma 4 would be in my relation K. And let me say minus 2 has to be related to 4 again, because minus 2 squared is 4. And again, if you are not very sure, you can check when x is equal to minus 2 and y is equal to 4, is this condition satisfied? That's what we are trying to do here. So minus 2 comma 4 would be in my relation. Now you will get the hang of it. 3 comma 9, square root of 2 comma 2, and pi comma pi squared, because all of these would belong to real numbers, and so on. Well, how do I get a better picture of this relation? So maybe I can use one other depiction of R cross R that we might have seen. So R cross R is a whole Cartesian product that will contain all the elements where the first entry is from real and the second entry is from real. And that can be one of the way that can be represented is with your xy plane, your Cartesian plane, right? Any point on this plane would be represented by the ordered pair x comma y, and that's exactly what we are doing to R cross R. So R cross R will be all the elements in this plane. Well, how would you depict your relation in this plane? Well, it would be all these points, right? All these points in the plane wherever they land, and hopefully we'll see some pattern. So let us start plotting. So let me get a few numbers on the axis. Let this be 5, 10, or shall we let us take 1, 2, 3. Let me draw the points outside the plane also if they occur. So, and this axis would have 1, 2, 3, 4, 5, etc. And we'll have a negative x also. because I see some relation, some elements are negative here. Well, this would be my axis, and let us plot these points. So 2 comma 4 is in my relation, 2 comma 4. Minus 2 comma 4 is in my relation, so minus 2 in the x and 4 in the y. And root 2 comma 2, well, root 2 would be, I don't know, somewhere between 1 and 2. It will be closer to 1 than 2, and root 2 comma 2 would be somewhere over here. Will 0 comma 0 be in my relation? We can check from this criteria. Is 0 squared is equal to 0? The answer is yes, so we'll put that element in K. So let me also put in 0 comma 0, because I have a place to mark it in my axis, that's why. So this is 0 comma 0. We'll also have minus root 2 comma root 2, that will also be in my relation, because minus root 2 squared is root 2. So minus root 2 would be somewhere here. And the other values are 3 comma 9, pi comma pi squared. So obviously you can plot pi comma pi squared, but I'm not going to do that. 3 comma 9 would be somewhere out here. So you can see that negative 3 comma 9 would be also somewhere here. So you can already see that it is forming a shape that we are very used to, or rather we might have seen in a few places. This is a parabola, and this parabola is exactly y is equal to x squared. If you don't know about parabolas and this is confusing to you, you need not worry, because we'll be covering all these in the future. But just for now, this is kind of the shape we are getting, and this relation is exactly what we have defined it to be, right? So we are getting a nice graph in our real plane, and this graph will be a subset of R cross R, and hence we are calling it a relation on R.